Hi, I am Lopamudra Sen. Welcome back to my channel Electronic Science Tutorial. Today I will discuss one of the important topic of NET question paper, that is based on junction field effect transistor. Okay, so let's start our class. So the problem is, in a JFET, the amplification factor mu, the transconductance Gm, and the dynamic drain resistance Vd are related as, first option is mu equal to Gm divided by Vd, second option is mu equal to Vd divided by Gm, third option is mu equal to Gm dot Vd, and the fourth option is mu equal to Gm dot Vd square. This question is from UGC Net 2012 paper 3 December Electronic Science. So how we solve this problem? This is the solution. Here we get the solution. First of all, what is transconductance of a JFET? The transconductance or the mutual conductance of a JFET is the ratio of the change in the drain current to the corresponding change in the gate source voltage for a constant drain source voltage. So Gm equal to ID divided by VGS. So this is the ratio. ID divided by VGS is equal to the transconductance of junction field effect transistor. And Gm is expressed in mho or ampere per volt. Okay. Next factor is the drain resistance, that is Vd equal to VDS divided by ID. So Vd, that means the drain resistance or the channel or the output resistance of the device, is the ratio of the drain source voltage and the drain current, and it is expressed in ohm, right? And the third concept of the amplification factor, that is expressed by mu, that is equal to minus VDS divided by VGS. The amplification factor is the ratio of the change in the drain source voltage to the corresponding change in the gate source voltage, and that is happen when we consider a constant drain current. Thus we get mu equal to minus VDS divided by VGS. So why this minus sign arise? Because drain source voltage and gate source voltage have always opposite sign. So this minus sign arises. Okay. But mu is always a positive quantity. Right. So how we get mu? We get mu, that is Gm dot Vd. If we simply multiply the transconductance and the drain resistance, we get ID divided by VGS into VDS divided by ID. ID and ID are cancelled out and we get VDS divided by VGS, and that is equal to mu, which is always a positive quantity. So the right option is mu equal to transconductance into drain resistance, that is Gm dot Vd. Okay, so this is the solution, And this is the very basic concept of junction field effect transistor. Okay, I hope you are all understand this topic. Thank you. If you like my channel, then please like, share and subscribe my channel. Thank you.